Hi there. I'm Rebecca Weaver. I'm going to be talking about solving linear inequalities today. We've got to get some notation down, so it'll take a little bit before we start solving the inequalities, but we'll get there. So first up, let's look at the real number line. I have a couple of real number lines sitting here for you. Um, it's just a line and it has all the real numbers on it. You can represent it. You can count by ones as I've done here. This number line, I've gone from -6 all the way up to 7. So -6, -5, -4, and I counted by ones and went on up to 7. You can plot points on this number line. To plot points, you're just going to put a dot on the number line at that value that you're plotting. So if we were to plot, say, -3, we would just put a dot there at -3. If we wanted to plot a 2, we just put it right there at 2. If we want to plot 4.5, we just kind of put it in the middle somewhere, right there in between 4 and 5. Now we can plot a range of values as well. So say we wanted to plot anything where x is greater than or equal to 2. So that would be like 2.5, 2.9, 3, 3.7, 3.5. So that's a lot of answers. That's a lot of numbers that x can be. So let's look at this number line and see anything that's greater than 2. See, I've drawn that line. So everything that's on that line from 2, 3, 4, and on up would be counted. Now that arrowhead, I call that positive infinity because that would be the furthest right or the greatest number that I can go to. So that would be positive infinity. Now to show that x could also be equal to 2, I need to have something really specific on there to show that. So I'll just put a dot on there, a closed dot. That's one way to do it. There's two ways that we have that we can do this. This is what we're going to look at first. Now the notation that you're looking at is called set builder notation. Whenever you're working your problem, sometimes your homework is going to ask for set builder notation. So if they do, they might be looking for x greater than or equal to 2, but they also might be looking for this formal set builder notation, which is a curly Q bracket, an x, and then that straight line down means the set of, it means, this is what it means totally. The curly Q bracket means the set of all, and then we have an x. That straight line down means such that, and then we have x is greater than or equal to 2, and then we end that with a curly Q bracket. That's formal set builder notation. Sometimes they're going to look for that. So if they're asking for a formal set builder notation, you'll put it in the curly Q brackets. You'll put your variable. Sometimes there's more than one variable. You might have an x and a y. You'd write x comma y if there were more than one. But when we're looking at these right now, we're just going to have one variable, so we're going to write the set of all x such that, that's what that straight line down means, x is greater than or equal to 2. That's formal set builder notation. So I want to show you this other way to graph. Here we have x is greater than 2, and what we do is we put, if it is greater than or equal to, we'll put a squared off bracket to show that it includes that endpoint. So you'll have to get used to looking at both of these two notations, both the closed dot meaning it includes 2, and the squared off bracket meaning that it also includes 2. This squared off bracket leads into what we're going to call interval notation, and your homework is also going to ask you to put things in interval notation. That would look like squarey guy bracket, then a 2, comma, on up to infinity. I usually like to write it right underneath my number line because I can see that that's where this comes from. I write that squarey guy bracket, I write my 2 all the way up to infinity, and infinity, whether it be positive or negative, always gets a curly, roundy guy bracket, so you'll want to put the roundy guy bracket on there. All right, so let's look at what this means. I just rewrote this greater than or equal to because it means that our set is inclusive. It includes the endpoint. That's how we would say that. So greater than or equal to is an inclusive meaning. So we still have our number line here, and I've written the two different ways, same as the previous slide. So let's look at what it means to have an exclusive type set, meaning that it's strictly greater than. That would look like x greater than 2. This is in set builder notation. Let's see what this looks like on my number line. If I'm going to draw this, I still would darken in from 2 and on towards the right to the greater numbers, 2, 3, 4, and the fractions in between. But to show that it does not include that endpoint, I'll put a circle, an open circle on the 2 to show it doesn't include the endpoint. It includes 2.000001, but it does not include 2. So what kind of notation do they want if you're not using the filled in dot or the open dot? Well, squarey guy bracket means that it includes, roundy guy bracket means that it does not include, and you'll just have to get familiar with both of these two types of notation because we use these types of notation when we're building our interval notation. So here's our formal set builder notation, the set of all x such that x is greater than 2. Interval notation, you will just write it straight down off the graph. That's roundy guy bracket 2, comma, infinity, close roundy guy bracket. And you'll notice I like to write it straight down underneath my number line. So if we're going to solve the inequalities, let's see what we would do. Now I'm going to do an addition subtraction because they don't have any differences here and it's pretty straightforward. If I'm going to solve x plus 4 is less than 6, just do this like I normally would. Subtract 4 from both sides. Then I would get x is less than 2. If I want to graph my answer, which sometimes they'll ask you to graph your answer, that means you're going to draw your line from 2 on. This is a strictly less than, so I would draw a circle that is an open circle for this one. If I'm going to graph this one with brackets, since it is strictly less than, he would get a roundy guy bracket on that too. So I would shade in all those numbers that are less than 2. So those are all the numbers to the left of 2. That would mean 1, 0, -1, -2, all of those types of numbers. So for set builder notation, I would write curly Q bracket. The set of all x, straight line down, means such that x is less than 2, in that with a curly Q bracket. Interval notation, I would write that straight down off the graph. Notice my left arrowhead is a negative infinity, so I write roundy guy bracket, negative infinity, comma 2, roundy guy bracket. All right, let's look at the properties of linear inequalities. Now, when you're adding or subtracting a number to both sides, the inequality sign is going to stay the same. However, dun, da, 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 when you are multiplying or dividing by a negative number to both sides, the inequality sign flips direction. So let's see what in the world is going on and what that means. If I have negative 2x is greater than 8, normally we'd divide both sides by negative 2, wouldn't we? The negative flips the direction of things. Notice how the bigger the number, the smaller it is if it's negative. So let's look at this. If it's negative, negative 6 is smaller than a negative 4. So let's look. These guys to the left are smaller, and the numbers to the right are bigger. All right. So what numbers might work for this inequality? Well, let's first try a 5. Let's see what happens. Negative 2 times 5 is negative 10. So is negative 10 greater than 8? No, sure isn't. So we know that 5 is not a solution to this inequality. Let's try a negative 5. Negative 2 times negative 5 is positive 10. Is 10 greater than 8? Oh, yeah, it is. So you know what that means? That means 5 is an answer. That means whenever I get my answer, that number right there, that negative 5, see where I put the dot on that negative 5? He better be shaded in. Multiplying or dividing both sides by a negative number flips the direction of the inequality because of the way the values change when they're negative. Always ask yourself when solving inequalities, did I multiply or divide both sides by a negative? Because if you did, flip that inequality. So if I divide both sides by a negative 2, I see that x is going to revolve about negative 4. Notice how the answers that are less than -4 work for this thing. That means we have that from -infinity all the way up to -4, but not including -4, works because this is an exclusive. So I'm going to put my answer on my graph. Notice how I have drawn this on my graph. Doesn't include 4, and I shade all the way to the left into -infinity. So we need to do a couple of these. Let's solve the following linear inequality. We have 3x minus 4 is greater than or equal to -10. I'm going to do the same thing I always do. I'm going to add 4 to both sides. All right, now you need to ask yourself this question. Did you multiply or divide both sides by a negative number? And I say, no, I added 4. So I didn't. So that means you keep your inequality symbol the same. All right, cool. So we can move on. Now I'm going to divide both sides by 3. You need to ask yourself the question. Did I multiply or divide both sides by a negative number? I say, no, I did not. That means you just copy down that same inequality symbol and you just write down what you have. That means x is greater than or equal to -2. Let's graph our answer because they're going to ask us to do it all. So if I'm going to graph my answer, I be sure and draw my line from -2 all the way greater than. So I'm going to go to the right. Notice how I'm going the direction of that inequality symbol. Notice how this inequality symbol is pointing to the right. That's the way I'm going to draw my line. And it's inclusive, so I'll draw a solid dot. I could also draw it the other way. Since it's inclusive, it would need a squarey guy bracket. Set builder notation would look like curly Q bracket, the set of all x such that x is greater than or equal to -2. Close it with a curly Q bracket. Interval notation, just draw it straight from that graph. I'd get squarey guy bracket, -2, comma, infinity, roundy guy bracket, closing it. Okay, so I didn't have to flip the inequality because I didn't multiply or divide both sides by a negative. Guess what I'm getting ready to do now? Let's do this one. Let's solve this following linear inequality. -3x minus 4 is greater than or equal to -10. I am going to add 4 to both sides. I'll say to myself, did I multiply or divide both sides by a negative number? And I say, no, I just added. Of course I didn't. So I'm just going to copy down my same inequality symbol and perform my operations. Of -3x is greater than or equal to -6. I'm going to write that down. Then I'm going to divide both sides by a -3, and I'm going to ask myself the question, did I multiply or divide both sides by a negative number? And I will say, oh yeah, I did. That means I better flip that inequality symbol and do my operations. I have x is less than or equal to 2. I'm going to need to graph this answer. I'll graph it. I'm going to solid line from 2 to the left towards those numbers that are less than 2. This would have a solid dot because it includes that endpoint. Doing it for the bracket, I do the exact same thing, but this time I'll need a squarey guy bracket because that means it includes that endpoint. Writing it in set builder notation, I'll have curly Q bracket, the set of all x, such that x is less than 2, ending it with a curly Q bracket. Interval notation means that I'm going to write it straight off the graph. Notice how that arrowhead with the -infinity is darkened in. That means this is going to be open parenthesis, -infinity, comma 2, squarey guy bracket. And that is solving linear inequalities. Once you get used to the notation and what they're asking you for, it gets better, but trying to get used to it at first is sometimes difficult. So if you need any help, be sure and email me. And have a wonderful day.